Hello, students. Welcome back. Hope you guys had a wonderful fall break. Mr. Campbell here is back after a solid fall break as well. I see a lot of you have turned in some work online, so I will be grading that very soon, updating that as soon as possible. So again, we've got that notebook check. You guys remember that? That was posted, notebook check 5, right before, the Friday before fall break. So make sure you get that notebook up to date, get that all situated so you are all set with your grades as we finish the semester here. We're already almost in December. So that means I think our semester this year actually ends in January, and it's only gonna be 5 weeks left. So make sure you're up to speed and on top of all your classwork as we move forward here. So that includes the project, which I think I'm gonna push back actually one more week because I know a lot of us are needing to get ahead on that. So please move forth on that, get ahead on that a little bit as we go ahead. But other than that, there's a project. There's the article analysis that's due this Friday. We've got the volcano activity that a lot of you have done. Make sure you complete that. And I think we might have another short quiz this Friday, so be ready on the lookout for that. Number 1, what are the 9 ways that geologists identify minerals? I will give you some of that because I think I've only shown you like 5 of the 9. 2 is on page 13, by the way, guys, page 13. What are the softest and hardest minerals in the world? We talked about mineral hardness before we left off on our live Zoom lesson before fall break. 3, what is the least reliable mineral characteristic of them all? The least reliable, we're gonna find that one out as well. Let's check it out. Number 1. They include crystal form. And again, you're already going to be having this written down on page 12. So if you want to write all these down, you can, but it's already going to be written down on page 12. So, I mean, it's up to you, however you like to organize your notebook. Crystal form, luster, hardness, cleavage fracture, streak, color, special properties, texture and density, and specific gravity would be the included 9. Moving on to number 2. Hardest is going to be diamond. Diamonds are the hardest minerals in the world, where the softest is this kind of white, this white opaque mineral here, which we call talc. Okay, softest mineral is talc. It's so soft, in fact, you can scratch it with your fingernail. Very, very soft, right? And then number 3, the least reliable mineral property is going to be, guys, color. Okay, just because a mineral is blue doesn't mean it's always going to be sapphire. Just because a mineral is red doesn't mean it's always going to be ruby. You guys understand? Okay, so make sure you write those down on page 12 as your answers for your Go Blue as we go ahead and move forward. Table of contents, I think there might be a little update here. Make pages 13 and 14 ocean topography. Again, pages 13 and 14 ocean topography. Okay, have that ready to go. And here is our video question of today, guys. What is a mineral and what are 4 examples of them? Again, what is a mineral and what are 4 examples of them? Because we're talking all about minerals, you might as well know what a mineral is, what the definition of it is, right? Okay, let's go ahead and check that out. Oh, hopefully you guys, give me 1 second. Again, I'm not going to show all the video, but I will show just the first parts of it, right?
Hey there, our goal in this video is to examine what exactly a mineral is and take a look at what criteria must be met for a substance to be considered a mineral. So let's dive right in. We'll start with the question, what are minerals? In the most basic sense, minerals are the building blocks of rocks. They are what make up the rocks that we find on the surface of the Earth, throughout the solar system, and throughout the universe. Let's take a look at a rock. This is an igneous rock known as diorite. And what probably jumps out at you are all the different speckles of color, the dark grays, the whites, the orange. And what those are actual mineral crystals. The rock diorite contains mineral crystals of plagioclase, feldspar, biotite, mica, amphibole, quartz, and others. And so when we're talking about minerals, let's keep in mind that they are what make up the rocks on the surface of the Earth. Now, there are many, many minerals that exist on Earth. Here are some of the more common minerals. Some of these you may have heard of, including things like quartz.
And we've got all our examples right there, guys. So this video, I've answered the question for you in this video alone. They are the building blocks of rocks. Because rocks, basically, like think of rocks like a smoothie. Think of minerals as the fruit, okay? Minerals are pure, rocks are a mixture of minerals. And then there are plenty of examples there. Quartz, sulfur, garnet, pyrite. That's our fool's gold, right? Graphite. That's used in our pencils and our pencil lead. So Plenty of examples there. I gave you the answer in the video itself. Let's go back to page 12. We just got 4 quick topics to go over, and then we've got, because we left off last time on streak in our Zoom lesson. So go to page 12. We got to know our 9 mineral characteristics, and let's continue here, guys. We've got color, like we just learned about. Again, same minerals can be many colors. Least useful mineral identification factor, because many minerals are many colors. Okay, so like sometimes we get, I know quartz can come in different colors, I think. So many minerals can come in many colors and sometimes the same color. So it can get really, it doesn't purely identify what the mineral is. Next one is special properties. Super important, guys. I just want you to know the key terms here, but list these off on page 12 under the term special properties. Again, we're on page 12. This is in your notebook on page 12. Could be a notebook check page. Keep that in mind. And we got double refraction. Splits light into 2 rays. So does the mineral split light into 2 rays when it goes through? Effervescence, fizz. That means, like, does the mineral produce like a fizz? Sometimes when we find minerals in the wild, they're greasy or soapy. They can have like a fizz on them. Magnetism. Does the mineral have attraction to metal? Which just know, y'all, I think a lot of you guys already know that, right? Iridescence, a new word here you guys probably don't know, is when the mineral bends light rays. So as you see in this little prism here, does it bend the light rays into many colors, right? Kind of like the colors of the rainbow. And then fluorescence, I know most of you have probably heard of this term. Does the mineral glow in the dark? Does it glow in the dark? Let's do our last question of the day before we go over our last 2 topics. Oh, oops. Clicked on the wrong thing, I guess. Oh, hold on a second. Got my computer screen messing up. All right. So what type of erosion creates sandbars? What type of erosion creates sandbars? Is it water, wind, gravity, or water and wind? And as you guys can see there, it is water and wind. Water and wind. So I need to pick a different question because that one already had the answer on it. I'm not a fan of that. So let's go ahead, check out another question that helps us know our stuff here. Let's see here. Which question do I want to use? One second, guys. I'm just looking around. We talked about deposition, right? Well, oh, I think I found one. Sandbars was the one we saw. I saw deposition, but I just lost it, guys. I just lost it. Not my day, I guess. All right, let's do this one. This one is deposition. Oh, no, this is a good one. This deposition structure helped protect coastlines. Which is it going to be? Is it A, beach, B, sandbar, C, delta, or D, barrier island? Pause the video, see what you think. The answer is going to be, guys, letter D, barrier islands, hence the name barriers. Okay, D, barrier islands. All right, let's go finish up for page 12, guys. Texture, as we know how a mineral feels. Okay, it could be smooth, rough, ragged, as I said earlier, greasy, or soapy even. That kind of falls into that fizz stuff with the special properties. So in texture, you guys have heard this term before. How the mineral feels is one way we identify it. And then lastly, guys, if you want to mathematically identify it, again, this is added to page 12. Add this to page 12, guys, all this stuff. Density and specific gravity. This is the last and 9th special property of minerals. Density equals mass divided by volume, guys. So again, that's just kind of like we're measuring it, we're getting a feel for it and all that. And then this reflects the atomic mass and the structure of the mineral as well. So I'll keep those things in mind as we go along here, knowing the different ways to identify minerals. But if we're going to do a mathematical way of doing it, it's going to be density and specific gravity. That concludes our YouTube video lesson of today, guys. We'll be back on Zoom tomorrow. Stay up to track with your work. I'm going to be grading it. I'm going to be And we're going to have, I think, a parent conference line coming up. So make sure your grades are up to date and or your work's up to date. And if you have any questions, always feel free to message me on Canvas. This is Mr. Campbell signing out. Have a wonderful day.